Okay, it's straight up 12 o'clock on my end here in the world. So yeah, let's go ahead and get started. So my name is Paul Nishihira, and I hope that everyone attending is having an amazing day. And thanks for joining in this GoEngineer webinar. It's going to be on CAMWorks High Performance Toolpaths, 2.5 axis and 3-axis VoluMill. And just a couple of housekeeping items here. If you do have any questions, I will be able to answer them, but it'll be towards the end of the session. Everybody else in attendance is going to be on mute for right now. So again, if you have any questions, just put your questions in the chat box down below. And also at the end of the webinar, I will have a email address. So if you wanted to do any type of follow-up questions, I will have some contact information. And then one last item is this video is going to be recorded. So it probably either later this afternoon or maybe early sometime next week. If you do want to download it from the GoEngineer website or even GoEngineer, youtube.com, you can go ahead and check it out there as well. Okay, so let's go ahead and begin. So the most common question that I have, and this is more geared towards individuals who are not familiar with the differences between 2.5 axis and 3-axis toolpath, is that with the 2.5 axis toolpath, it's the capability to translate in all 3 axes, but the cutting operations can only be performed in 2 of the 3 axes. So in this example right here, if we were to take a look at the toolpath in blue, it'll go ahead and move in X and Y directions simultaneously. And then once it reaches its position, it'll go ahead and move down in the Z direction. So again, it'll start at the 0, which is the top surface, and then drop down to level number 1, and then move around in X and Y direction. And then once it reaches its position, then it'll move down into level number 2. For 3-axis toolpath, it's a little bit different. You got a lot more algorithms and things going on in the background, and the biggest thing really is moving simultaneously in X, Y, and Z. This is a great application for very organic surfaces or surfaces that tend to create a lot of very complex or unique geometry. Okay, so I went ahead and showed my isometric view and a little side view right there. So you're going to be seeing some marketing terms here, and some of them are going to be known as high-speed machining, high-efficiency milling, and of course trochoidal milling. And all of these are actually advancements in the metalworking industry, and what they do is they're creating a high-performance toolpaths for efficient removal of materials. And in the CAMWorks family, it's no different. We have something called VoluMill. Okay, it is by Accelerative Technologies. It is fully integrated inside of the CAMWorks programming scheme, and it's made up of 2 words. It's the term volume plus milling, and it manages the rate of material removal for consistent machining loads. And the great thing about this is that the toolpaths that it's generating is that there's no sharp corners. Everything is very smooth and stress-free. And the nice thing about all of this is that it'll extend tool life. It'll engage the material to the full flute of the tool length, and you're going to get better usage and control of that cutting tool. So if you're not familiar with VoluMill, it's a slightly different approach as far as the machining approach to removing material. With traditional machining, the focus is on a smaller axial depth of cut, and then also as far as the radial depth of cut, which would be your step over. That will indicate how much material is being removed. So with this type of operation, and it could be anything from like a pocket in or a pocket out routine, but you're going to be focused on more of your depth of cuts and how much you can take, and as far as your chip load there. The other thing with traditional machining is that it's going to follow the offset profile. So if I have a, as in the example on right there, say, even though I have a radius corner, it's a rectangular pocket. So starting in from the inside, there's a sharp transition. And this is what we like to term shock loading of the tool. So it'll be traveling in a X or Y fashion. And as soon as it hits that sharp corner, it's just going to make a 90-degree transition going into the other direction. And for those of you who are familiar with doing any kind of pocketing machining, you know, everything will sound fine, and then all of a sudden it gets into that one corner, and then you're going to hear like a chirping sound, or as I like to affectionately call, the machine is barking at you. You know, and that's where you have the loading and unloading of the tool and the cutter inside of the material. So with VoluMill, the approach is a little bit different. They focus on a larger axial depth of cut. So in this illustration, we're going to be using the entire flute length, but at the same time, we're also going to be specifying a smaller radial depth of cut. And the nice thing about this is that it's going to allow us higher machining loads, so we can increase our RPM, we can maximize the usage of the tool, the cutting tool itself. Maybe it's a high helix, it's a multi-flute, whether it's in for soft or hard materials, and it's going to give us higher feed rates as well. The other benefit to VoluMill is that it doesn't have any sharp edges. So if you can see with the image on the right side there, there's a lot of arc movements, and it's just constant engagement of material. And the cool thing about that is that it puts even pressure or even loading on the cutting tool, so you're not going to have chirping, if at all, when it gets into like sharp corners and whatnot. So for this first model in this illustration right here, I'm going to talk about the 2.5 axis milling. And what I'd like to do is machine this interior pocket portion of the part here. And I went ahead and just to save a little bit of processing time, I did create a couple of toolpaths, traditional versus VoluMill. And again, this is at the 2.5 axis level. Okay, so if we go in with the traditional rough milling here, and then let me go to my roughing tab. You know, we have a pretty good selection here that CAMWorks offers. We can do anything from pocket in, pocket out, zigzag, spiral in and spiral out. That actually benefits circular type pockets, or maybe oval shapes, you know, if you wanted to do something like that. We can even do plunge roughing or even offset roughing, you know, if you wanted to. And then of course down here we have VoluMill, which I'll get to here shortly. So what I did, just to make sure that I compare apples to apples, I utilized another program, and it's part of the CAMWorks installation. It's called the Milling Advisor, just to maximize the roughing portion of this particular geometry. And again, you know, I went ahead and specified my depth of cuts, and then also my step over here, and this is rated at 50% of the diameter of the tool. So again, if I went ahead and toggle it, you can see that it's stepping over 0.375. Now, the thing about this is that, let me go ahead and hit preview and start stepping through this here. Some machines may not have the ability to do like a spiral or maybe a ramp in. You know, some machines will have just the ability to plunge into the material, but just to kind of keep things fancy, I'm going to go ahead and spiral in right here. So at first glance, if it's using a center cutting tool, it ramps in pretty nice, and then as soon as it reaches its first Z depth value, it's going to start milling. Now this is where the traditional pocketing routines will be an issue, because it's actually creating kind of like a channel right here, and this is where you're going to need either a very strong coolant blast to evacuate the chips so it doesn't load up the flutes of the end mill, or maybe even like an air pressure, high air pressure to where it evacuates the chip. Okay, so here again, you can see that it's just focusing on the tip portion of the tool. So there's pretty much unused area kind of up in this upper portion right here. Okay. So again, I'm going to go ahead and just step through it a little bit more. Another thing to worry about is is right over here when it makes the transition. As soon as it engages the material, that's where that barking or that chirping sound is going to happen. And it's not so much as if you have a very short tool and a rigid setup, the amount of loading and unloading of the tool, as far as the sound goes, it's not going to be too drastic. But if you have a fairly long tool, maybe an extended reach, you're going to get a lot of excessive chatter. Okay, so I'll just go ahead and run this out here. All right, and then there's our part right there. Okay, so the biggest thing everybody asks is, well, that's kind of cool, but what about the time? Okay, so here again, I went ahead and dialed in my feeds and speeds for this portion right here. So let's just go ahead and open that up. And now keep in mind that the optimization time right here, it's roughly just under 8 minutes. Okay, keep in mind that number one, it's going to have a brand new tool. It's going to be fully optimized. My workpiece, it's in a very rigid setup. The machining center, it's in fairly good condition. It's got a lot of horsepower and whatnot to maintain the spindle speed and the feed rate. And then I'll go here to the feed and speed tab. So again, it's pretty conservative, because I'd like to start things with conservative rather than breaking tools on the first get-go here. Okay, so let's go ahead and check out the VoluMill next. Okay. All right, so the VoluMill is a little bit different in the sense that number one, it's a lot of arcing movements, and then number two, I'm going to go ahead and go to the roughing tab here. Is that you have a little bit of control available to you in the sense that it's very specific to the VoluMill type software, as well as tools related to high-speed machining. You can control the entry and the retract. Other options here where you can increase the smoothing radius, and you can even override specific settings. So maybe you have a tool that's a little worn, or maybe it's too conservative and you want to go and you want to push it a little bit farther. It's definitely an option that you can do with the VoluMill settings. Okay. In addition to that, if we go to the feed and speed tab and making sure that we're under the operation selection, you have access to what we call a VoluMill technology expert. So I'll open that up right here. And the cool thing about this is that it takes all of this information. So it could be the type of material, it could be the material hardness, the coating of the tool, as well as the different types of part holding, the machine taper, and then even the end mill holder type. All of this is taking this all into consideration to give you very conservative to aggressive feeds and speeds. And the other cool thing is that you can just use this very easy slider bar, just move it up and down and kind of see where everything is at. Okay. And then once you're happy with a specific setting, you can just hit OK, and then it'll go ahead and update the values here for your feed and speed tab. So again, I'm going to go ahead and cancel out of this one because I did optimize it here down below on this other one. Now I'll just go to edit definition, and then we'll go ahead and again, we'll go to the optimize tab, and you can see that we're at 4.7 minutes. So it's almost about 50%, but I'll go ahead and show you the playback mode in the simulation. Okay. So again, spiral in is pretty much the same, but once it hits the floor, that's where the differences begin. You can see it's constant engagement. There's a lot of arcing and constant loading of the flute of the tool. It just provides a very nice cutting type operation for this particular geometry. Okay. So I wanted to also highlight a little bit about the VoluMill. There is a little manager that is included with the CAMWorks installation, and it's called the Milling Advisor. And this actually complements the VoluMill settings inside of CAMWorks. So you can use this kind of as a guide of sorts to find out, it's like that next step if you want to maximize the tool that you're using, the coding, the part holding, and then the base recommendations down here. It is from the manufacturer Helical, and if I go to the About tab here and then go out to their website, bring that up here. Okay, it's actually under, they also have Representative Harvey Tools. So the nice thing about this whole collaboration is that not only do you have access to the VoluMill, but also the milling advisor, as well as the cutting tool in itself. So in combination with all of these technologies, is that you can get the maximum usage and efficiency out of all of your tools, specifically for VoluMill. I'm going to go ahead and change gears here, and whoop, there we go. And let's go ahead and we'll do this other one right here. Okay, so here again, it is what we call a 2.5 axis part or a prismatic part. It's just a square floor. It's got a couple of bosses that's raised up, and the nice thing about this is that in it, and I'm actually going to be stepping into the 3-axis machining mode now. You can actually take this geometry and use what we call a multi-surface feature operation. What this does, it'll go ahead and read the entire model, but it'll think of it as an application from a 3D side of the house. And the cool thing about this, it opens up the next door, which is the VoluMill 3-axis milling. So inside of there, I'll go ahead and open up the VoluMill example here. The controls are pretty much the same. Again, if you go to the feed and speed tab and then the operation as defined by, you still have access to the VoluMill technology expert. And in this material, for this particular material, it's going to be aluminum, so it's a little bit easier to cut. But all of the controls for the parameters are there, and then you have the recommendations and the slider bar down here below. Okay. In addition to that, if we go to the pattern tab, we have access to the VoluMill settings. And again, you can control the ramp in, the entry length, the floor distance, all of the overrides. All of this control is still available to you at the 3-axis level. Okay. So again, for the sake of saving processing time, I went ahead and did create a part that's been dialed in. So as the statistics go, we'll go ahead and say, okay, well, it takes about 4 minutes to rough out that part. So we'll go ahead and run it here. Okay. The one thing you're going to notice about the 3-axis VoluMill is that it starts outside of the part and it engages the material accordingly. So this is where the advantage of the constant loading of the tool. There's really no shocking where there's interrupted cuts. It's always engaging material, and it's going to not only, number one, bark at you, but number two, it'll extend tool life. And then, of course, when you have that factor played in, you're going to be saving tool costs because you're not going to be buying as much tools. Okay. All right. So let me go ahead and pause that. Now, one thing to consider in all flavors of CAMWorks is something called adaptive milling. Okay, so let me go ahead and bring that up. Adaptive milling is similar to VoluMill. There are some differences, and I'll go ahead and talk about them here shortly. But the approach is pretty much the same. It uses the full length of the tool, or the full flute length of the tool, and it engages material and applies the same type of geometry as VoluMill does. Okay. The biggest difference, though, is that, and again, I went ahead and dialed in my feeds and speed tabs so that we're comparing apples to apples, is that you're going to notice a difference in time right here. Okay, so that's the big one right there. With adaptive milling, it will go directly right into the part. Okay, and the other thing too, this is going to take a little bit while to run. But I did want to show you that not only does it go right into the part, it also will wrap it rather than feeding as VoluMill does. The other thing to keep in consideration, let me go into the adaptive mode here. You don't have access to this VoluMill technology expert. Okay, so that's one. So if you desire any additional control, there is none available. It's one of those, and you can look at it this way. If you wanted to keep your programming as simple as possible, you just say, hey, CAMWorks, I want you to rough this out. Let's use adaptive, and you take care of the algorithms that's running behind, and that's totally fine. If you want a little bit more control as far as the entry and how the tool is engaging, definitely VoluMill 3-axis is the way to go. All right. So the organic part, if you notice that we have a lot of unique shapes going on here, and let's go ahead and do a little bit of statistics comparison. Okay. So here again with the adaptive milling, it looks like I'm running, this is a fairly small part, which is why I'm roughly, let's see, my time is like 0.425 minutes. So it's pretty good amount of time for roughing out this particular part. And again, I'll go ahead and run it here just to let you see what's happening. And again, this is adaptive, so we'll go ahead and run it. So here again, it is going right into the material, but it's still applying the same type of high efficiency milling where you're using the entire flute length to engage the material and have or minimize any type of shocking of the tool in itself. Okay. Actually, let me go ahead and fast forward this here. All right. One thing you're going to notice with adaptive milling, because it does plunge or ramp into the material, you're going to get these little scallops here kind of towards the end of the part. Okay, and this is one of those things that you are not able to control. Like I said, with adaptive milling, once you click on that button, it is what it is, what you get. Okay, so let's just kind of keep that frame of reference in mind there. Okay, so we'll go ahead and go to VoluMill, and let's go ahead and check out the statistics tab. The other thing you're going to notice is that the toolpath looks very, very different from adaptive. Additionally, it's almost cut in half. You got 0.246 minutes of machine time right there. Okay, but here's the other cool thing. So let me go ahead and run it. Whoops, that's too fast. Let me switch the gear here. There we go. And then I'll go ahead and start. Right there. My initial entry is going to be outside of the part. And again, if this is something that you desire, definitely VoluMill is the way to go. And then I'll go ahead and run the rest of the simulation right here. But again, it's the same technology as adaptive, but you have a little bit more control available to you. It's still engaging the material for constant loading. And the other thing you're going to notice is that we don't have those scallops here at the very end. It's a very nice clean tool path. And when you go in with your maybe a ball end mill or maybe a bull nose end mill for finishing work, those finishing tools will have less material to worry about. So feature comparisons. So between 3-axis VoluMill and adaptive roughing, the major ones, and I could go very granular as far as the nuances between both, but as a general overview, more control. So 3-axis VoluMill, you have access to the technology expert interface, the VoluMill settings, and of course entry outside of the material. With adaptive, and again, it's a great roughing strategy. You just have less control that you can utilize. Under the CAMWorks matrix, so we have different bundled packages. So anything from CAMWorks Standard to the CAMWorks Premium package. 2.5-axis VoluMill is included with all packages. So it's one of those things you don't have to worry about. It's already included. And if you're doing prismatic shapes, straight walled pockets, maybe bosses, or constant angled, like tapered faces and things like that, 2.5-axis VoluMill does a fantastic job. When you get into the adaptive roughing, and again, this is CAMWorks now, because it is a 3-axis roughing strategy, it is not available in the standard CAMWorks package. However, from Milling Professional up to Premium, it is available. The 3-axis VoluMill is an added module, so if the parts that you're doing has very organic shapes and you do a lot of them, this is something that you may want to consider as. Okay, so yeah, if there's no questions at all, definitely, you guys have a great Friday, if not a great weekend. And again, if you have any questions after the fact, feel free to utilize the support at goengineer.com. And in addition to that, this webinar will be uploaded in video format. So if you go to the GoEngineer YouTube channel, my information will be out there for everyone to see post-webinar. So with that said, thank you very much for attending this lunchtime webinar, and you folks have a great day.